All right, welcome to your Algebra 3 final review videos, numbers 18, 19, and 20. We're getting ready for that T1 final. 18 says, are the polynomial functions graph below even or odd? Remember, even or odd comes down to symmetry. So you have three options for symmetry. Well, I guess actually two. The first one we care about is y-axis symmetry. If a graph is even, sorry, I gotta click my pen, even, it'll be symmetrical across the y-axis. So that means that if I draw my graph, I should be able to fold it along this line, toot, 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 the one up and down, and it would lay right on top of each other. Good news, graph 1 does that, so graph 1 is going to be even. Now, if I have odd symmetry, then it should be rotational symmetry. And what that means is that I should be able to rotate it about the origin. So 0, 0. So if I start right here, I should be able to take this part of my graph and turn it so that it like somehow matches. Now, the only thing is when I turn this graph, the whole thing kind of follows with it. So when I turn that one, it's never going to actually end up on itself because we're taking the whole thing and it'll just be like do, 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 do. My next one, if I turn this, whoop, it'll end up on itself. So I would say this one is odd. Another way to think about it is this one sort of looks like an x squared graph, which is an even number. This one almost looks like an x cubed graph, which is an odd number. Mostly, if you can fold it right across the x-axis, you're good. It's even. If you could turn it, and it would wind up on top of itself or look the exact same, then it's odd. My next one says, what is the equation of y equals x cubed with the given transformations? You want to make a horizontal translation left 1 unit and a vertical translation up. Okay, let's talk about translations for a second. When you do your translations, you're going to have like three options. It'll be like y equals a times x minus h squared plus k. Now this number out front, it's a stretch. Let's zoom a little bit so I can actually write, and then we'll come back and do the problems. So this number out front stretches it or shrinks it. The one inside moves it left. It'll move it left if it's a positive number. It'll move it right if it's negative. Now this is kind of counterintuitive because if I go on a number line and I go towards the left, I have my negative numbers. Towards the right, I have my positive numbers. So it's the opposite of what you think it would be. And then the last one, my k, moves it up if it's positive and down if it's negative. I would write this on your note sheet. In fact, I would write something maybe more eloquent than this, but I think it'll help you. So the first one says we have a horizontal shift left 1 unit. So that means we're going to have y equals, and my left shift is inside here. So we're going to have x, and if it's shifting left, it's positive. So we'll go plus 1 squared, and then a vertical translation up 1 unit. So that means I need a plus 1 on the end. And I know it's plus 1 because if it's moving up, it's going to be a positive. Now my next one, we need a vertical stretch by a factor of 6. So we're going to have y equals, and then we'll put a 6 out front. And we need to shift 4 units to the right. Remember, if I'm going right, it's going to be a negative, and it's on the inside. So we have x minus 4. Oh, sorry, these were cubes, so that should be a cube. And then a vertical shift 3 units down. So that means I do minus 3 because I go negative to go down. And those are your answers.